Okay, so I'm going to do a quick review of how nucleophiles attack at the carbonyl carbon. I know my students have seen this a lot, but I think it's really important, and I know that not everyone who follows me on here is one of my students, but this is like the major pattern that happens in organic chemistry 2, starting from like chapter 16 on through the rest. And yes, I am in my bathroom doing this video because my husband's doing dishes in the other room, and we have a very small one-bedroom apartment, and I need a counter to write on. Okay, so up to this point, we've seen the same carbonyl chemistry over and over. The nucleophile will attack here. These electrons will kick up. And as a result of these, the same thing will happen. So when these attack, the nucleophile attaches right here, and the carbonyl carbon will kick up. Now, if there's a good leaving group, this carbonyl carbon will come back down, and the leaving group will leave. And you'll get a substitution with the nucleophile here, the leaving group's gone, and another nucleophile can come in here attack. If that doesn't happen, then usually this will be protonated with some kind of alcohol or with some kind of acid to make an alcohol, and this will be your final product. So you either get another ketone that can be attacked by a nucleophile again, or you're going to get an alcohol. Either of those are going to be totally fine. You can stop here, or if you have this one, an excess of the nucleophile, it can keep going and keep reacting. So that's the basics thing that we've seen over and over for this chapter, and I really want, or these chapters, we saw this with Grignard reagents, we saw this with Fischer esterification, so I really want to make sure that you can see this and take it in and you recognize this pattern. But for imines and enamines, a new thing can happen after that. So imines and enamines kind of pick up from right here, but what happens next is actually this alcohol gets protonated again from usually acid in solution with like some H+, to make this OH2+, and hopefully you recognize that's a good leaving group. So actually, this could come here to form a double bond, and this can be kicked out. Sorry, that's a curved arrow, but it doesn't look very good. And basically do an elimination reaction to create not another carbonyl or another ketone, but your nucleophile. In this case, it would be a primary amine or a nitrogen, to make a nitrogen double bonded to the formerly carbonyl carbon. And that's sort of a new realm of carbonyl chemistry that we're introducing, but it starts with the same way, it just adds in elimination reaction. Enamines are a little bit more complicated, they have one step beyond that, but these are the basics that you're going to see in chapter 16. Hope that review is helpful, and let me know if there's anything else I can do to help.